Alright, what's up? Here we go, guys. Example 1. Oh! Anyways, it says, what is the constant and proportionality of the graph? So, we talked about this yesterday in Zoom class. In order for you to find the constant and proportionality, we have to find what are the ordered pairs of this graph. So, I already know that this is proportional because it's a straight line, it goes through the origin. And if it's proportional, it means all of these ordered pairs equal the same number. Okay, so we just have to find what is that number. So the first thing you're going to do is you're going to find, and what I wrote down here is the ordered pairs. So that's the first thing we're going to do. So remember, this is my x-axis, that's my y-axis. And so the first ordered pair, so remember, it's always in x, comma, y. So ordered pair, I'm just going to write number 1. What we have is 3 for x, 1 for y. So here, I'm going to write, 3, comma, 1. Okay, that's the first one. Number 2, you have 6 and 2. So 6 was x, 2 was y. Next ordered pair, what I have is, we got 9 for x, because that's again my x-axis, so 9 for x, and then 3 for y. So we're going to write 9, comma 3. Okay, and if you wanted, you could do the last one, which is 12 for x, 4 for y, right? So I'm going to put 12 for x, 4 for y, and it's super important to make sure that we are correctly assigning the value to the right variable. So these are my x values, these are my y values. So in order for me to find the constant and proportionality, I'm going to create a table. So now we have x, we have y, and so I could take, just like we did on the Nearpod, I'm taking my ordered pairs and I'm writing them down as a table, right? Because my first number is x and my second number is y, so we could just transfer that. So this would be 3, 1, 6, 2, 9, 3, 12, 4. So the important thing to remember is that we already know this is proportional. We already know that. That means that in this table, they all are going to equal the same thing. And so what I notice here is a lot of you are going to say that the constant proportionality is 3, but it can't be 3 because the constant means we're multiplying my x value by a certain number to get my y value. Okay, so what I have to do is, for the last step, remember, if we want to find our constant, I don't know what times 3 gives me 1. I'm going to now divide then y over x. So the first one, y is 1, x is 3, so that would be 1 over 3. And 1 over 3 can't be simplified. But what I do know is all of these actually equal 1 over 3 because it's a proportional graph. So I'm getting 2 6, 3 9, 4 12. And yes, all of these simplify to 1. Whoa. Oh, so sorry. All of these simplify to 1/3. We already know that. So if I divide this by 2 over 2, that's going to give me 1/3. If I simplify this by 3 over 3, that equals 1/3. If I simplify 4/12 by 4 over 4, all of these are the greatest common factor. They all give me 1/3, which means my constant of proportionality is 1/3. If I multiply 1/3 by all of my x values, I would get my y values. So you are going to type right here 1/3. So that's your answer. Oh, literally type 1/3. Now, what is the equation now that represents this graph? So this is what we talked about again yesterday. My equation is always in the form of y equals k times x. And so what I know now is that k equals 1/3. That's what I know, which means I'm going to substitute k for my equation. And for this specific graph, it would be y equals 1/3 x. And so what you notice here, we're going to type for our equation y equals 1/3 x. And don't put any spaces in between, just leave it, just literally don't press the space button. Just leave it as y equals 1/3 x, just like this, which makes sense because all of my values, if you notice, if y is 1, that means the distance between each point goes up by 1. And if x is 3, that means I'm going 3 points on my x-axis, 1 point on my y. 3 points on my x-axis, 1 point on my y. 3 points on my x-axis, 1 on my y. So each one has the same exact distance of 1/3 between each point, which is why it's also proportional. So that is example 1.